Hi everyone, I'm Gil Elizov, VP Product at Gilat Satellite Networks. In the coming minutes, I want to talk with you about the new technologies that are emerging in the satellite communication world. As we all know, a lot of new satellites are being launched and added every day. Those satellites are no more just GEO satellites, also MEO and LEO, multi-orbit constellations that are emerging and bringing a lot of new capacity into the world. The drop in the prices that this reflects is also already being seen in the market and will continue to be seen as prices will keep dropping and enable more and more services all around the world to many new applications and customers. Satellites that has a lot of capacity in multiple orbit are also coming with new technologies as software defined, which means that the satellites become smarter and now they can be played and changed dynamically throughout the day, throughout the year, in order to allow more services and more capacity all around the world for new applications. This brings the challenge of adding cloud into the ecosystem of satellite communication in order to be able to cope with a lot of capacity, multiple orbits, and new services. As always, this bandwidth needs to be managed efficiently and deal with the dynamics that now satellites introduce when you have multiple orbits, software-defined satellites that can be adjusted and changed over time, over day, and bring new challenges into the management of those kind of networks. When we look on the technology side of all those things, there are three main pillars that drive the change for satellite communication in the coming years. Multi-orbit support, virtualization, and standardization. I will try to touch all those three in the coming slides. Multi-orbit offering is something that we are seeing more and more crucial in the satellite communication world today. There is a true global coverage of three constellations, LEO, MEO, and GEO, all around the world, giving a lot of connectivity options to customers, a lot of satellites that can be utilized to bring more services into the satellite communication world, into new services that satellite operators can now offer. The desire to have a multi-orbit system consists of two parts. First of all, having a single platform can work on multiple orbits and multiple satellites, and having a single modem terminal that can work on multi-orbit and multiple satellites. There are various use cases for that kind of services, and having a LEO with low latency, a GEO with high latency but much better coverage, and a MEO that is in between gives a lot of use cases that satellite operators can use in order to offer new kinds of services all around the world. If it's a backup services, when one constellation can be a backup for another constellation, or having two constellations working in parallel by utilizing each one of them best for the applications, there are latency sensitive applications that will enjoy the LEO and MEO connectivity, while there are applications like IPTV and multicast that will enjoy the GEO coverage to bring better services. All of that gives a lot of use cases that service operator can use in order to extend their service offering in the market. Multi-orbit is a good promise, but if we look on reality today, that might change in the coming years, of course, is that we're still not there. The LEO constellations that we are seeing today are a closed garden environment, meaning that there is no interoperability between the various LEO constellations and between LEO constellation and GEO constellation. When we look, for example, on the challenges on the terminal side, on the antenna, having LEO and GEO that supports only KU, there is no MEO in KU, meaning that you can use KU only for certain kind of constellation, while if you want to use KA, you can use it in MEO and GEO. Maybe in the future there will be some LEO constellation as well, but still there is no one antenna that can serve all the different orbits that are out there. When you look on the modem side, it's the same thing. Having a LEO constellation as today as a closed garden, meaning that a LEO terminal cannot work on other LEO constellations or even on a GEO or a MEO constellation. And therefore, when you want to have a multiple orbit service today, you need two modems. When you talk about MEO and GEO, it's a little bit different today. If we look on mPOWER and GEO in KA, then a single terminal using Gilat modems can serve those kind of constellation today. Virtualization. Virtualization is a critical pillar when we look on the new satellites and the new world of satellites that is coming. When you have a lot of capacity deployed all over the world on different kind of orbits, you need a single solution that can serve all of that. And since otherwise you cannot have a single solution, the solution is to move into the cloud. It can be public, it can be private, but something that runs on a general purpose kind of hardware can allow us to expand into new orbits and new capacity much easier than in the past and provide a scaling that is not dependent on a single type of hardware or single type of vendor. When we look on the traditional ground segment that we saw in the last years, there are several challenges in order to move into a virtual environment. First of all, proprietary hardware that is being deployed on the gateways. Adding to that, dedicated servers that is being utilized in order to achieve best performances. Unique switches architectures and configurations that are unique per network and per vendor. And on top of all of that, the IF-RF interface between the gateways and the antenna is high maintenance and very hard to scale when we talk about multiple orbits and a lot of new capacity and satellites. Moving into a digital platform, which is virtualized, is the next stage for the ground segment in order to allow the connectivity in multi-orbit environment and a lot of new capacity. Having a digital interface between the antenna and the gateway, where everything will run over Ethernet fibers and not dedicated IF-RF cable, will bring the ability to connect to much more satellites and much more antennas than before. Virtualizing the modems on the gateway in order to be able to run over off-the-shelf hardware and not a dedicated hardware will allow the move into the cloud, even if it's a private cloud, of the gateways. Same goes for the data centers, having all the data center applications being run as a CNF, as a cloud-native functions that can be virtualized over any type of hardware in any type of cloud, will allow the expansion of gateways and data center into new world and more locations than before. All of that will require, of course, an orchestration, a cloud orchestration that is orchestrating this entire digital platform, but also connecting to the satellites and orchestrating the software-defined satellites with the ground segment that is fully virtual. When we talk about virtualization, we are talking more than just changing the technology and running over cloud. Virtualization means that everything in our organizations, it's the service operator, it's the vendors of the equipment, everyone needs to be able to change and to adapt to this new virtualization world. Having sales, delivery, operations, support, production, everything supporting virtualized platforms in all levels, on the service operator side and of course on the vendor side. A major part in moving into the cloud and making a virtual platform is standardization. Today in the world, you all know, every operator, every vendor has its own unique technology with its own unique characteristics. In order to be able to run in the cloud and allow interoperability between various constellations, standardization is required. Standardization can come in different places, in different shapes. Standardization of the waveforms, of the protocol, of the services, of the interfaces. Not all of it needs to come at once. There should be some kind of a phase of changing everything, but it's clear that in order to achieve interoperability, efficiency, cost saving, there is a need for standardization. MEF is an example of standardization on the data layer, allowing end-to-end connectivity based on MEF Ethernet is crucial in order to achieve large-scale networks. Different types of MEF connections are being defined by the MEF forum, and having that part of a solution is crucial in order to allow the interoperability and to allow the service orchestration for service operators. Another part of the standardization is the 5G NTN. 5G NTN brings into the table two things. One is the radio and one is the core. 5G new radio means that you need to change the waveform and to create a generic waveform that can operate with different type of vendor modems. On the other side, 5G core allows us to integrate services that are applicable for the cellular world into the satellite world. When we look about the 5G NTN, it's mainly driven by the 3GPP in main three releases that are coming. Release 17 was already released, and we are starting to see the first implementation of that, but it's mainly aiming for the low bitrate kind of application. Release 18 will come most likely by the end of this year or beginning of next year, and will provide extension of more capabilities into the satellite world. And Release 19, that will be more or less about 2-3 years from now, will bring the support for regenerative payload over satellites and allow multi-orbit connectivity. 5G NTN is a crucial part in migrating and standardization of the satellite world. When we combine that together, we at Gilat see the evolution of the ground segment in two phases. One phase that are orthogonal to each other, by the way. One phase is virtualizing the gateway and the data center and allowing a virtual world to work over any type of cloud, public or private, with the existing waveform and with the existing services, and one foot on the ground kind of approach that allows service operators to maintain their current deployment, the current services, and extend into cloud services and to new capabilities. And the other part of it is adding new capabilities like the 5G NTN into the network, into the same ecosystem. At the end, having a multi-orbit environment with different kind of waveforms that can support different kind of application, running over cloud, connecting into a 5G core, and allowing services end-to-end to be in the satellite world as it is in the cellular world. This kind of multi-waveform architecture also allows customers and service operators to maintain their current investment in networks and not change everything before moving into a new approach of new services. To summarize, our industry is going through major changes. A lot of new capacity, a lot of new satellites, multiple orbits that are coming, and this drives the need to change also the technology that we are using and the way that we use this technology. As I mentioned, three pillars are the basic for that, which is multi-orbit support, virtualization, and 5G NTN as part of the standardization of the satellite communication world. We in Gilat see that as the future of satellite communication networks, and it's aligned with our approach with our SkyEdge 4 platform, which is a proven platform that already supports multi-orbit today, and is also a milestone in moving into evolution of virtualization and multi-waveform support to enable new services for satellite operators in the coming years. Thank you.